Our bucket stores commodities collected by the scoop and dumps them into the starting area. This is controlled by a button multiplied by a constant block of 127. The output of the motor can be viewed in our simulation. Our aluminum swiper is used to collect the aluminum from underneath the broken pipe. This works by our button input being multiplied by a value from 0 to 255. This can be seen here in the lower region clearly than it can be seen in the upper region. The output can be shown here. Our arm is used to scoop up commodities off the field during the game. This is controlled by a motor. This button input is multiplied by an arm fast speed or an arm slow speed. The processes are the same except for the different speeds. The button input is multiplied by the arm speed, which is controlled by a constant block. This is then added to the arm down, which is multiplied by a negative value of 1 to create a reverse direction in the motor, and then multiplied by the arm speed, which would create the same amount of power in the down direction. This is then added to create a single output to the motor, which is then inputted into the maximum output control system. If the fast arm and the slow arm buttons were both pushed together, this would create a value over 127, and that would cause the motor to overload. So these two inputs are added together and the maximum value is controlled inside the add block. This sends one single output to the motor, which can be displayed here. Our wheels use a complex mathematical formula to allow for finer motor controls at higher speeds. This mathematical equation is used in both subsystems for the left and right wheel. The only difference between the two is that the right wheel has an inversion, creating a reversal in the motor direction. This is needed because the motor is placed on the opposite side of the robot to the other. The formula used can be shown here. We first start with the right joystick input not being allowed to equal 0. This will prevent a divide by 0 error in the if statement. Inside the if statement, the joystick input divided by its absolute value. This controls the motor's direction. The most important part of this equation is the input from the joystick divided by a constant of 127, which acts as the motor's maximum input, which is then set to a power of 2. The input is divided by the constant to create a value between 0 and 1, making the exponential curve, which allows for our higher motor controls, less dramatic. This is then set to the power of 2, which creates the exponential curve specifically chosen to our driver's preference. Both of these outputs are then multiplied by the maximum speed. These outputs can be shown in simulation here. Our shaker is controlled by a pulse generator that generates a value between 0 and 200 every 0.5 seconds. This is then subtracted by 100 to create a negative value in between the two pulses. We use this pulse to make our wheels and our arm both move up and down. This is to either clear commodities out of the shaft of the scoop or to empty the commodities into the starting area.